Hello, everybody. I'm here with an example of pulley systems, different configurations. As you could see here, 5 different uh, forms of the way we can, support a load here. And let's say if you are told that the weight of this uh, block is, say, 60 pounds. So that's the weight. So that's given. In each case, I want to calculate the tension or the force needed to keep this in equilibrium. So this guy is not moving, the block is not moving. So this is a very simple problem. And the way you do that is, by the way, is you look at the free body diagram of the pulley that is attached to the block, basically. So, and I can actually show you the free body diagram on each of these diagrams. I don't have to redraw it. So if you look at this pulley first, right, you already know the weight of this guy is 60 pounds, right? And you got a tension here. By the way, based on the assumption that friction is negligible in pulleys, then if you have one cable, that cable going around so many pulleys, right, the tension is going to be the same. So we know this is T, therefore this side will have equal to T. So here we would have, in this first 2T summing forces or balancing forces in the Y direction. Therefore, you only need 30 pounds to keep this in equilibrium. So this is A, right? So what about B? We'll do the same thing. We'll look at the free body diagram. So again, we have a 60 pound here. We just have to look at this, right? Tension. Remember, this tension here coming around is the same tension everywhere, right? So again, look what happens. 2T equals 60. So this one is exactly like case A. The only difference is that, let's say it's difficult to pull up. It's more convenient to pull down to keep this in equilibrium. It's just the way the load is applied. Okay? So now, let's look at case number C. Again, we'll look at the free body diagram of this. By the way, these are a little bit crooked. These are, suppose you could actually make the configuration in such a way that all these forces or cables are acting vertical. But in any case, let's take a look at the free body diagram here. 60 pound again. Look, again, the tension here, this tension, T, right, is the same cable here, T, and going around, and the same tension here, T. So in this case, you could see that 3T is equal to 60 pounds, and T becomes 20 pounds. So far, case number C is the best one, is the most efficient one. We're taking advantage of the pulley. So you're only applying a third of the load to keep this in equilibrium. Let's take a look at D, guys. Again, we'll look at the free body diagram. 60 pounds here, right? So this cable tension is the same everywhere. So this is T. This is T. This is T. So, kind of like C, even though it's a different way of applying the load, 3T is equal to 60, therefore T equal 20 pounds. So you see, again, C and D kind of like B and A and B were the same situation here between C and D cases. Now, E is going to be a little bit different. So let me see if I could show you free body diagram. So first of all, if you just concentrate on this guy, right? And let's say we know the tension is T. So this is T, this is T, right? So the load here would be what? 2T, which means the load here should be the same as, sorry for moving that, the load here should be also, let me just redo this, guys, 2T. I keep moving my diagram. So we have a T here, and a 2T in the middle. So basically, this is what you have. The free body diagram is going to look like this. The 60 pound here, right? a T, 2T rather, sorry, in the middle, and a T here. So you end up getting a 4T equals 60, which will give you a 15 pounds. So case E is the most advantageous case or the most efficient case. Again, I can redraw this free body diagram over here of this pulley. You see, you have a T here, you have a T here, therefore you have a 2T like that, and then you see the same 2T here in that rod, right? This one acting on this pulley which is attached to the block. So we had the 60 pound here. Basically now I'm going to get this free body diagram. You see that 2T in the middle, and then of course a T over here, this one, and a T over here, this one. That's why we have 4T equal to 60, and as a result T becomes 15 pound. Okay, as always, thank you for watching, and if you like the videos, just subscribe, and we'll have videos every week. Thanks again.